Control of motors can be achieved either through traditional low-voltage electrical appliance control circuits or through the use of PLCs. Let's explore the differences between these two control methods. A low-voltage electrical control circuit consists of two main parts, the main circuit and the control circuit. The main circuit is the primary electrical path from the power source to the motor, carrying a high current. The control circuit, on the other hand, is composed of buttons, switches, contacts, contactor coils, and other components connected by wires, and it typically carries a low current, not exceeding 5 amperes. When transitioning to PLC control, the main circuit remains the same, but the control circuit is reconfigured. Buttons are connected to the PLC's input terminals, and the PLC's output terminals control external devices such as contactor coils. The complex wiring of the low-voltage electrical control circuit is replaced by a control program written for the PLC. By comparing these two methods, we understand that traditional electrical control is purely hardware-based, while PLC control replaces the low-voltage electrical control circuit with the PLC's I or O wiring diagram and ladder logic program. Let's further discuss the differences between relay symbols and PLC program symbols. The coil of a relay is represented by one symbol, while the output coil in a PLC program is represented by another. The normally open, NO, and normally closed, NC, contacts of a physical relay are represented by specific symbols, and their quantities are fixed. For instance, an AC contactor typically has only 2 pairs of auxiliary NO contacts and 2 pairs of NC contacts available. In contrast, PLC programs use different symbols for NO and NC contacts, and the number of PLC relay contacts is virtually unlimited. This means that when programming, we are not constrained by the quantity of contacts needed. Now, let's examine the correlation between relay control circuits and ladder diagrams. Pressing SB1 closes the corresponding input relay I0.0 in the program, energizing the AC contactor KM coil and the output relay Q0.0 in the program. Releasing SB1 opens the input relay I0.0 in the program, but the KM contact remains closed, keeping the output relay Q0.0 in the program closed as well. The AC contactor KM coil remains energized, and the output relay Q0.0 in the program remains activated. When SB2 is pressed to break the circuit of the AC contactor KM coil, the corresponding input relay I0.1 in the program is activated. The normally closed contacts of I0.1 in the program open the circuit of the output relay Q0.0 coil. Note that in the PLC program, whether I0.1 is used as an NC or NO contact depends on whether the stop button SB2 is wired to an NO or NC contact. If the stop button SB2 is wired to an NO contact, I0.1 in the program should be an NC contact, and vice versa. Generally, we prefer to wire the stop button SB2 to an NO contact when programming. Next, let's delve into the programming languages of the S7-1200. The S7-1200 supports ladder diagram, LED, and function block diagram, FBD. A ladder diagram is composed of contacts, coils, and instruction boxes. Input contacts represent the PLC's logical input status, and output contacts represent the status of the corresponding output coils of the PLC. Instruction boxes are used for timers, counters, mathematical operations, and other instructions. Ladder diagrams are the most commonly used programming language. Function block diagrams use blocks similar to AND, OR, NOT gates to represent logical operations, but we typically prefer ladder diagrams for programming. The design of a PLC control system for motor start and stop must follow 5 steps. 1. Analyze the control process based on task requirements, retaining the main circuit. The purpose of this analysis is to determine the number of input and output signals, which are the controlled objects. There are 3 input signals: the start button SB1, the stop button SB2, and the overload protection FR. There is 1 output signal, the coil of the relay KA, which is the controlled object. 2. Based on the analysis, compile the PLC's I or O allocation table. The start button SB1 is connected to the PLC input I0.0, the stop button SB2 to the PLC input I0.1, the overload protection FR to the PLC input I0.2, and the PLC output Q0.0 is connected to the coil of the relay KA. 3. Design the PLC I or O hardware wiring diagram according to the PLC's I or O allocation table. Connect the PLC's power supply and load power supply, and connect SB1, SB2, FR to the PLC's input terminals I0.0, I0.1, I0.2. Connect the PLC's input common terminal 1M, and the PLC output terminal Q0.0 is connected to the KA coil. Why is there an additional circuit on the right? Because the PLC output is DC 24 volts, which can only control a small relay KA, and to control a motor, an AC contactor KM is necessary. Therefore, we use the contacts of the DC relay KA to control the coil of the AC contactor KM. 4. Write the control ladder diagram based on the control requirements. When the start button SB1 corresponding to I0.0 is pressed and activated, the control output coil Q0.0 is activated. To maintain the activation of the output coil Q0.0 after releasing button SB1, a self-locking contact of Q0.0 is parallel below the I0.0 contact. When the stop button SB2 corresponding to I0.1 is pressed and activated, the output coil Q0.0 must be deactivated, and an NC contact of I0.1 must be serialized in the line of the output coil Q0.0. Similarly, when the motor overloads, the corresponding I0.2 is activated, and the output coil Q0.0 must be deactivated, with an NC contact of I0.2 serialized in the line of the output coil Q0.0. In the program, the addresses I0.0, I0.1, I0.2, Q0.0 correspond to the names of the variables displayed below. 5. Install the wiring and download and debug the program according to the PLC's I or O hardware wiring diagram. This lesson primarily introduces two methods of motor start-stop control, namely the control design of PLCs. For the detailed implementation process, please refer to the next lesson, which includes creating a project, hardware configuration, writing a program, downloading a program, and debugging a program. This lesson is now concluded. Goodbye.